Today we'll start talking about least squares regression lines. We won't actually be calculating regression lines today. We'll just be interpreting slope and y-intercept and making predictions and starting to begin to learn about residuals. A regression line is a line that describes how a response variable, a y value, changes as an explanatory variable x changes. And the form of this regression line should look really familiar to you. It kind of sort of looks like y equals mx plus b, but it's switched around a little bit and using different variables. So it's y hat equals a plus bx. So let me tell you about all of that. So we want to distinguish between the actual y values and the predicted y values. So because of that, we don't just use y equals, we use y hat, literally y hat, and that's the predicted value of y for a given x. The a is what you might think. It's the y-intercept, and it's the predicted value of y when x equals 0. Notice it's not the actual value of y when x is 0, but the predicted one. And then the slope, the b, is the amount that y is predicted to change when x increases by 1 unit. So let's look at an example. The scatter plot shown gives the number of miles driven and the price of a random sample of 16 Ford F-150 trucks. The equation for the regression line is price hat equals 38,257 minus 0.1629 times the number of miles driven. So this is y hat equals 38,257 minus 0.1629x. We'll let x be the number of miles driven. So if we want to interpret the slope, we know the slope is the b, and it's negative 0.1629. And this tells us that for each additional mile driven, the price of the truck is predicted to decrease by $0.1629 or 16.29 cents. And the y-intercept, the value of a, is 38,257. And this tells us when the miles driven is 0, perhaps when the truck is new, the price is $38,257. So now let's use that same equation to make a prediction. Suppose I want to predict the price of a used Ford F-150 if it has been driven 100,000 miles. So I'll use that same equation of y hat equals 38,257 minus 0.1629x, and I'll let the x be 100,000. So minus 0.1692. Did I write that? No, that's supposed to be 29. I'm sorry. Let me see if I can fix that. 29x times 100,000. So this gives us a predicted price of $21,967. Now, let's talk a bit about extrapolation. Extrapolation is the use of a regression line for predicting far outside the interval of values that we had originally for the x values. And that's just because those values aren't often accurate. And that just means, we don't really want to make predictions for values far outside our data set. For example, maybe I don't want to try to predict the value of the car if it's been driven, say, 250,000 miles. This particular regression line may not be accurate for predicting that far outside our range of values of x. And then finally, residuals. So what happens here is we're trying to find a line that goes through our data as best as possible, and so models the data as best that we can. But unless the data is exactly linear, no line's going to pass through all of the data points. So what we're going to try to do is make the vertical distance between the actual points and the line as small as possible. And you can see that in the little picture I have here, that I'm showing you some values of residuals. So the idea of the regression line is that we'll make those vertical distances as small as possible. But those vertical distances are called residuals. So today what we want to do is just kind of talk about how to find a residual and what that value means. So a residual is the difference between the observed y value, so our actual data value, and the predicted y value, or the one that we got from the regression line. So let's look at an example. Find and interpret the residual for the Ford F-150 that had 70,583 miles driven and a price of $21,994. And I think that's this point right here. So I'm actually trying to find what the vertical distance is from the actual data value to the line. So in order to do that, I'll have to go back to my regression line. Y hat equals 38,257 minus 0.1629x. And I'll have to substitute in my miles driven to find the predicted price. So that's 38,257 minus 0.1629 times 70,583. And you can use your calculator to figure out that that gives me 27,000. No, I'm sorry, it does not. $26,759. So then my residual is the actual price, y, minus y hat. The actual price is $21,994 minus the predicted price is $26,759, and that gives negative $4,765. And you can kind of see that this data point is below the regression line. So what that means is that the actual price of this truck is lower than we expected it to be based on its mileage. You should now go onto Blackboard and complete the quiz that you see there for this section.